welcome to our 20th Fusion Friday. My name is Alex Alvarez.
My name is Mongkolpoonsuk.
And we're application engineers here at KETIV Technologies. So I do notice that we have a couple of attendees. So just a quick overview on what Fusion 360 is, right? So we have a couple new attendees. It's a series of webinars where we go over all the workspaces that Fusion 360 has to offer, right? As well as some of the updates that Autodesk has for Fusion 360. So for today, we are going to be talking about reverse engineering meshes. So that's actually a very popular topic, right? Not that we only see in the forums, but that we also see people calling in and asking questions about, right?
Yeah, actually in our rendering webinar, this was requested by one of you guys to do this topic. And we're glad we chose it because we got a lot of good feedback and a lot of good attention regarding this topic. So hopefully you guys learn a little bit about meshing today and reverse engineering.
Absolutely, yeah. So again, at the end of the webinar, we are going to have a survey that's going to really ask you questions about how we're doing, and not only that, but what do you want to see in the future, right? What topics do you guys want to see us make or really focus on in the upcoming webinars, right? So again, with that, I'll go ahead and hand it over to Brian and get it going.
Sounds good. Thanks, Alex. So what exactly is a mesh? 3D meshes are 3D models that are made up of polygons. Usually they consist of triangles. If you look closely at the picture here on the right, you can see that there are little triangles that make up this mesh in particular. And I can kind of tell that this is a scan data because there's a lot of patches that's shown in the yellow. If you guys can see that on your screen, showing that those aren't completely filled in parts of the scan. And meshes are important because one of which I was just talking about is that we are working with scanned files for a lot of these STLs. So pretty much when you scan an object, it produces a mesh, and that's usually 9 times out of 10 what the file type you get from it. So that's why it's useful to know how to reverse engineer one. Because usually these meshes, you're unable to edit them. You can't really push-pull them. If you use something like Mesh Mixer, you have more of a flexibility in terms of how you want to edit them. But comparing that to like a 3D model or something like parametric modeling, you can't really compare those two. You can do a lot more with parametric modeling and things like that, and surface modeling. Meshes are also in simulation. So when you want to do like a thermal simulation, static simulation, event simulation, it converts it into a mesh first, and then the software runs the calculations based off the mesh. Next, we have 3D printing. So if you guys have ever 3D printed before, you can notice that your 3D printer, preprocessor, or your slicer, whatever you want to call it, takes in STL files. And these STL files are cut up into thousands of different layers, and then it's used for 3D printing. And lastly, it's a common file type. Most standard CAD software can import and export STL files because of these three reasons that I listed here. And for more reasons, you can convert yours into an STL file so that other people can't copy your files, like for proprietary data and things like that.
Yeah. So what you were referring to, Brian, in simulation is more or less in the event simulation, right? So once you actually run the analysis, it's going to give you an STL file or a mesh that you can then work from, and then really base your new design off of.
Yeah, exactly. That adds to generative design, which is one of the tools that Autodesk has as well. Today's goal will be to reverse engineer mesh into something that's editable. And also for you guys to ask questions. Today is going to be a little bit longer of a webinar, guys, because we have a lot of content to go over. So bear with us, and also ask those questions. We'll gladly address them at the end, or at least try to. And if not, then we'll contact you personally about the questions you ask, because your question might be similar to the other questions that other viewers are watching. So we can kill 2 birds with 1 stone with these questions here. So let's hop into Fusion. So first, let's go ahead and bring in an STL file. To do so, we would go over to the data panel, And there are two different ways to bring in files like that. You can go new design from file, but the way we recommend is to go through the upload way. This way is different because you have the ability to upload multiple different file types as the ones you see here, because it uses the Fusion 360 translator to bring in the data. If you do the new design from file, that only lets you bring in about 5 different file types. But if you do it the upload way, then you have more options. And once you select your file, we actually got our files from grabcat.com, one of which is a DeWalt Power Tool interface to Makita battery adapter, posted by SG down below here, as well as the Audi 2.7 T intake manifold scan by Marcus. So thanks for those guys who uploaded this for us. And once I hit the upload and I selected those files, they come into the data panel on the left-hand side here. So let's take a look at our first example, which is the DeWalt to Makita adapter. So this is typically what you see when you bring in an STL file. It's usually that purple color. If you go over here to the bodies, it's represented by this yellow cylinder representing the mesh body. Also, even if you have your units as defaulted as inches, it does come in as millimeters, only because whenever Fusion brings in foreign files, it brings it in metrically. So you can still go in here and change it to inches, but just be aware that it comes in as millimeters. Also be aware that when you do bring in file types like this, you don't have it doesn't show the design history. One, because it doesn't have one, because it's a dumb body, like we like to call, where you can't do anything really to the model. But also the benefit to having the design history turned off is that you're able to edit your model in a way where you don't need to worry about the order anymore. You also have quick access to the sculpt environment and the mesh environment over to the left-hand side here. And if you want to turn on your design history, you can right-click on your top-level component and hit Capture Design History. But we're going to leave it off for now because we want to convert this mesh body into a body representation, or what we call a B-rep. And that's a surface body that we can edit. But in this case, actually, it's a 3D body. So we're actually going to convert it to a B-rep, which is a solid B-rep. Hopefully that makes a little bit of sense.
If you had the capture design history turned on, you wouldn't be able to convert it to a B-rep, right?
Right, exactly. So what I'm going to do here is right-click, and then I have the or I have to get in the model workspace, and then I have the mesh to B-rep option. But with the design history turned on, we don't have that option. So I'll go ahead and do this first. To show you guys. So I selected the mesh body that I want to convert to B-rep, and it's giving us a warning that this mesh contains a large number of facets, 13,468 to be exact. Those would be the triangles that you see here that appears, and the conversion is not recommended. We're going to proceed anyways, but usually you want to stay below 10 or 9,000 facets to get something that converts. Fortunately, it did convert for us, and it gave us this 3D body over here. However, let's say we had 20,000 facets and it did not convert for us. Then what do we do then? So then I would want to reduce the number of facets, so then to about 10 or to below 10 or 9,000. So we're going to go over here to the mesh workspace, and there's a tool called Reduce that reduces the number of facets while trying to still maintain the shape of the object. So yeah,
sorry about that, Brian. But this is also a common issue that people are always facing when working with STLs, right? A lot of times what we see is they send it out to a different software maybe to reduce the mesh there. Mm-hmm. They might not be aware that you can do that in Fusion 360, right? But you know, Brian's showing you a quick and easy way to really refine your mesh and then define how many facets you're going to have in that mesh.
Yeah, exactly. That's a good point. We do have that option in Fusion here. We even have a dedicated workspace for working with meshes here. So I'm going to reduce the number of facets now. And before I hit OK, I want to see the density that's occurring here. So if you remember, it was 13,000 facets. If I did 0.5 over here, then that would be about 6,500 facets. If I did 0.25, that would be 37 or 3250 around in terms of facets. And we can also click this preview checkbox to see the difference between the 13,000 facets and then what we're going to get now, which is the maybe 3,300 facets. So once I did that, we have less facets to look at now. You can tell the number of facets you have by right-clicking on your model and going to Properties. We have 3,300 facets. So now if we go back to that model workspace, we can try to convert this to a BREP, and now it shouldn't give us that warning. So now it's represented. Now we have this 3D body represented by this gray color, which is the default in Fusion 360. And if you look at this, it consists of a lot of BREP faces, but it's actually a solid body. So these faces are like the polygons that we were talking about earlier, except now we can edit them. So if I want to extrude this face, for example, I can do that. But I don't want to extrude just the triangle of this face. I actually want to extrude the entire, let's say I want to extrude the entire, all four of these faces combined instead of one at a time, because that's really what you want to be able to do. So what you can do is start hitting delete on your keyboard to delete some of these faces. And now you're putting them all in the same plane here. Because if you look at it, like this one, for example, they look like they're all in the same plane, but they're barely not. And that's why they created it like this. But now these are for sure all in the same plane. So now I can extrude it out all as one body.
And that's going back again to having less facets on your model, right? So try to find that balance between the model accuracy and how many facets you can get away with. Again, the more facets you get, the more accurate your model is going to get represented. Mm-hmm. But then you're going to run into issues like this, right, where you're going to have multiple facets, even though it's going to be a flat face, right?
Right.
That you're working with.
Right. And keep in mind, reducing the number of facets does affect the shape of the model. In this case, it's so parametric that it didn't. But if it's a really complex shape with a lot of facets, which we'll see in a second, it will change the shape of the model a little bit. So what I'm doing here is I selected two of these faces. And let's say like we don't want to have this pocket anymore. So we can do things like delete. And this is one of Fusion's features, which is a direct edit modeling feature, which it deletes those two faces and repairs it in respect to the surrounding surfaces of the model. You can do deletes, but you can also do extrudes like I showed you earlier. For example, before I extrude, I want to extrude this face up to this plane here. I would need to delete all these faces, so then it's all one clean face. So then, once again, E for extrude, just like a regular parametric tool that we're used to. And then I'm going to extrude it up to this surface here. And then it gives us that clean face. It doesn't come with the sketch still, but you are able to really edit this very efficiently, rather than just that mesh that we couldn't do anything with before. So this is one way of editing or reverse engineering your model or your meshes, is to directly translate it into a body representation. And then you can do what I just showed you guys there. So next, let's take a look at the 2.7T intake manifold here. So this was a scanned part. And if you take a look at the number of facets it has, it actually has 432,000 facets, which is quite a lot of triangles there. And this isn't something we can simply convert to body representation. What you can try doing is cutting some of these faces and just focusing on one portion of it. So then you have less facets and just reducing that and doing that each at a time. Or you can work with T-Spline technology. And what T-Splines is, it's a faces, edges, and vertices that are organic and ergonomic that you can wrap around like a ceramic wrap around this model. So we're going to go ahead and go into our sculpt environment, which contains those T-Splines. And what I'm going to do first is actually create some cylinders around this model and use what is called the pull command, which gives us that ceramic wrap kind of behavior to this model. And it's located here in our modified panel. So before I use that command, I'm going to need something to pull to the surface. In this case, I'm going to create cylinders. So if you guys are used to the T-Spline environment, then this is really familiar to you. If not, then you can start learning now. So I'm just going to go ahead and put in the cylinder. And I'm going to move it into location into where I want to start pulling the surface to the body, to the mesh. And you want to make sure that this surface isn't too close to something that you don't want to be pulled to, because then it won't pull in the manner of which you want it to. So right now I'm trying to get away from this feature down below here and that feature up below, up there. Now I want to make sure it's positioned pretty well. Maybe move it over there a little bit more. And then I also want to create another SRAM wrap or pull feature at the top of this cylinder here. So what I'm going to do is just Control-C, Control-V. Now I have another cylinder that's ready to manipulate. Now, I'm not saying this is the only way you can reverse engineer this model. There's many different T-Spline approaches you can take. This is just one of the main ones I think for those of you who are new especially should consider. So I want to put this into position to where it's not close to, so it's not pulling to anything I don't want it to pull to. That's pretty much parallel with the model. All right, so now we can go ahead and use that pull tool. I'm going to window select my T-Splines and notice how it moved a little bit based off the vertices because it pulled to the closest surface to it. So to give you guys a better image, I hid my mesh body. Now you can see that it gives us kind of that curvature that we're looking for. And the fact that it's showing a little bit of purple and a little bit of the T-Spline is really good because that means it's very low or high tolerance. It's like hugging pretty much like a ceramic wrap around the model. It's not going to be 100% to the model, but it's going to be very close. So what we can do now is actually connect the two edges here from this edge to this edge. So we can use a merge command, we can use a bridge command. But notice, even though it did bridge it, that's not the shape that flows with the cylinder here. So what we want to do actually, instead of bridge, or instead of bridging yet, is we want to create some faces manually on this surface here. So how I'm going to do that is I'm going to use the face tool. And I want to create 8 total faces that wrap around the cylinder. I chose 8 because that's the number of faces that exist on the existing cylinders. And what you want to make sure you do is line up these faces to the faces you create and to these faces as well. And it sounds a little difficult, but it'll make sense once I start creating them here. So I'm turning object snap on so I can click on the surface itself. With it off, you cannot click on the mesh surface. So I'm going to go ahead and leave that on. And now I'm going to start creating these faces. And make sure these faces have 4 corners or vertices on them, because that's what the T-Spline reads the best. So notice how when I created my first face, it's a little hidden underneath the mesh here. That's so if you want to be able to see it better, so you can create these faces that go around and then eventually pull it as well, is you want to make this a little opaque or see-through. So I'm going to make the mesh body actually 20% visible. So now I can see my first face that I created there. So now I'm going to go ahead and make sure this next face that I create is going to line up this face, the face I'm creating, with this face down below here. Once again, this face, the face I'm creating, and then this face down below there. And it's going to get a little tricky around this corner. And I'm going to make my T-splines actually a little bit smaller. Oops, I missed it there. Now I'm going to match this face with this face. This face with this face. This face with this face. Now I can make it wider as well.
If you guys missed a step, or maybe Brian was going a little bit too fast, we are going to upload this to our YouTube channel, right? So for whatever reason, if you happen to miss something, or maybe you didn't quite catch or capture one of those steps, sometime early next week we are going to upload this video, right? So stay tuned.
Yeah, I'll try to go a little bit slower, just to make sure you guys understand what's going on. But yeah, like Alex said, it'll be uploaded so you guys can follow that video then. I just want to show you guys the idea and like the different approaches you can take. So notice now I've created my 8 different faces that goes around the cylinder. However, it is still it's actually a little smaller than the cylinder itself. So what we're going to do is what we did before, is use the pull command. Actually, I'm going to select this body and then do the pull command. So now I pulled outwards instead of inwards like we did earlier. So now we should have something that we can bridge together. And I'll do that one more time. With the bridge command, since this is 8 faces, I'm making 8 faces of my own to bridge to. You can also do increments of 8. You can do 8, 16, 32, so forth. For it to bridge. So now let me hide my mesh body. We have a surface very, very similar to the one that was created in the mesh. I say similar because, like I said, it's not exact, but it can get closer than a lot of the tools that we have out there. So yeah, next let's go ahead and try to create this cylinder that pops out of the tubing that we just created. So what we want to do actually for this one, there's different ways you can do this. The way I use is I actually delete these faces here where this exists, and then I use a match command. And a match command pulls the edges to a particular sketch, for instance. So I'm going to create a sketch of a circle and then pull my T-spline bodies to that sketch. So first I'm going to delete some of these faces, and it gives me that hole that I'm going to use for my match command. And then I'm going to offset a plane for this circle sketch to be placed on. So now I have a sketch that I can use. And now I'm going to use the match command. Select this series of edges and the target edge to match to. Now notice how it pulled the objects in a way where maybe we don't like it on this side, but it pulled more than we wanted to. We wanted to still kind of maintain that cylindrical shape. What we can do to fix that is go to specify tolerance. And once I click that, it already helped to fix it a little bit. But if I decrease the tolerance over here to 0.001, it matches it even more. And I can go even further if I want. And you can get more and more complex. But just keep in mind, the more complex it is, the more T-splines you're going to be working with. But to give you that more organic feel to the model, you want to go with the least amount of T-splines as possible. I'm not saying this is the best option for this. I'm saying this is a good tool to use for something like this. I can mess around with this some more, maybe change the edges in which I select or what the faces I deleted to prevent this from occurring, or maybe doing a fill hole command or deleting faces. But this gives you the general idea of it. You can also create a cylinder in the parametric workspace later after you create this. Combine the two and do a fillet that way. This is just one of the methods you could use. All right, and then once you do a series of wraps and adding faces or whatever tool T-spline tools you use, you'll get something more along the lines of this. So this is similar to, I use the same maneuvers as I did for the other one, but I also use the manually added faces to this surface over here, because you can't just add cylinders on this because it's a flat surface. So I manually added faces to this model. I made sure they were lined up so then I can get a nice flow and a look to my T-spline model over here. I use a series of match commands, a little bit more cleaner on this model as well, as you can see by these cylinders, as well as the figures on the bottom. I also want to point out that I use a flatten command along this series of edges. So pretty much I have a plane from the origin that I made these T-splines flatten to. And that could be useful if you don't want to create, if you want to create like a match command, except for a plane, matching to a plane instead of a sketch. And this one over here, you can see that's a little bit more ergonomic because it has less T-splines, and it looks a little bit cleaner. So it depends on the tolerance you're looking for. The more T-splines, the more accurate your result will be. And then afterwards, instead of having to recreate this model onto the right-hand side, you can use a mirror tool in the symmetry panel. And you can get something like this, where you don't have to work twice. You can just mirror what you already have, and then anything you do to one side will occur on the other side. So next, I want to talk about having another approach to this model. So let's say we did what I talked about earlier, which is we did a few cuts to the model. We just focus on parts of the model at a time. So now here I have part of that manifold, but just focusing on one of the cylinders. Now, the neat thing about this method is that we can really hug the surface of the meshes. So what I'm going to do now is I'm going to show you in here. Here's an example of it. Is I'm going to create a bunch of planes that are normal to the model, and then I'm going to project or intersect all the sketches onto those planes and then loft them together.
I guess you can say this is a more traditional approach, right, to when it comes to like surface modeling.
Yes, definitely. You can do this in the parametric or workspace as well, but the benefit of doing it in the Fusion sculpting environment is that you're able to push, pull, and manipulate your lofts rather than just worry about just being restrained to the sketches that you have. So I'm going to not do the whole thing, but I'm going to show you how I got it started. I'm going to offset a plane to the center, roughly the center of this model. And then I'm going to use the spline tool to create a line that goes through the center of the cylinder. And this is going to be used in conjunction with the plane along path tool in the construct panel. So I can move this around and adjust my spline. And I could delete some vertices as well if I think I have too many. And I also want to make sure it goes along the left side of this curvature of this cylinder as well. So I'm going to use a move copy command, right click, move copy, and I can move, I can move these vertices individually.
So for those of you that aren't familiar, this is essentially how you would do a 3D sketch, right? So again, do the sketch or make a spline, and then move those points independently, and that will essentially give you a 3D sketch inside of Fusion.
Right. So next, we can create the plane along path. And this creates planes that are normal to the path that you have. So for instance, if I drag this around, this is a very useful tool that I like to use. It's kind of fun to use as well. So if you notice the distance here, if I put 0.5, that's going to be halfway exactly in between along this path. If I put 1, that's going to be at the way end of the path. And if I put 0, it'll be on the other path. So what I can do, I can start maybe I'll do a 0.7 for this example. Right click and hold and release up to repeat the last command I did, and I'm going to do a 0.8. Maybe one more. Let's do a 0.9. So 70% of the path, 80% of the path, and then 90% of the path. Then what you're going to do is you want to use the intersect tool to intersect this body and the plane. So, but first, we got to make sure this body is something we can intersect with. Right now, it's a mesh body, and the intersect tool doesn't read well with meshes. So what we're going to do is convert this to a body representation, like we did in the DeWalt converter earlier. So notice how it's very diamond cutty, I would say, of a shape. But it does give us a good representation of that mesh. And this is something we can reference now. So now I'm going to use that intersect tool. And I'm going to create that intersection on this plane. And I'm going to use this body to intersect with. And it creates that sketch for us. I'll go ahead and use this tool again on this plane. And then on this last plane as well. So now we have 3 different profiles that we can loft to each other. So we can go ahead and try to do that. And we're using the T-Spline loft, so it'll create T-Spline bodies for us rather than the regular surface body. So if I try to loft from point A to point B, it's actually giving us a lot of T-splines, and that's not what we would want. It's giving us all these T-splines because of all the diamond-shaped cuts that you saw earlier. So now if we see a shaded version of this, we're getting kind of this very boxy-like loft. So instead of having something like that, what we can do is we can manually draw in our splines into each one of these intersects. So for example, if I go into the first sketch here, I can grab my spline tool and start drawing around this sketch. But before I do that, I want to actually get rid of this profile because I don't want to interfere with my new spline sketch. So I'm going to highlight all of it, right click, and make it a construction line. So now it doesn't have that murky yellow in the middle for representing a profile. So now I can start drawing my splines. And if you want to be really accurate to that diamond cut shape, you can click each one of these if you want. But I think you get a better result if you click with leaving some spaces in between them. So I'll select my last point, and then it creates that yellow murky spot in the middle, which means I'm ready to extrude, or it's a profile. It's telling me. And I could do that to this one as well. So making my way around, this is a spline, another spline, and I'll go ahead and leave it at two different sketches that I could loft between. So now with the loft tool in this T-Spline environment, I can loft from point A to point B, and it gives us a much cleaner surface. And if you do that a bunch of times, like I did here, you can get pretty much the almost exact surface. And it's a good idea, or it's a good thing that if you see here, the purple part of the mesh and the body representation that I just created are kind of overlapping each other, because that means they're very snug to each other, if you may. Also, this one is just showing this body over here is a cylinder I created in the parametric modeling workspace that shows another way you can create that cylinder there. If you created a cylinder and maybe added a fillet after combining them, you can get a good result as well. All right, lastly, I want to show you guys how to directly edit the model the mesh once you bring it in. So let's go ahead and get rid of this T-spline body. And I'm going to make this visible again. And now let's say you get a mesh like this, and you want to just do a little bit of a manipulation to it without having to change it to a body representation and going through that whole process. Thankfully, in the mesh workspace, we have editing tools like fill hole, reduce that we used earlier. We can delete faces, merge bodies, and so forth. So let's say, for instance, you want to get rid of whatever is going on down below here at the belly. You want to make this a smooth surface. So what we can do is either try the smooth tool or the erase and fill tool for that. So right now, if I try to highlight this paintbrush that I'm using is actually a little bit too big, and it's getting other objects that I don't want it to touch. So what you can do is go here to the mesh palette and decrease that brush size. So now I have a much smaller brush size that I can use to paint, if you may, the parts that I want to make smooth.
So this was a question too while we're on this topic. Brian Dodds asked, can you clean up the number of facets on the fillets like you did on the flat faces? So I'm assuming he was referring to the first model that we were talking about with the flat surfaces. Mm-hmm. So this is how you would essentially just refine the mesh to more of a controlled surface. Mm-hmm. Right.
So yeah, so I think it would be the reduce tool that he's mm-hmm. looking for that would reduce the number of facets in a particular area mm-hmm. instead of the whole thing. Mm-hmm. And you have that option to preserve boundaries where you don't want it to reduce meshes at all. But that's in the reduce tool here. All right, so what I'm going to do now is try the smooth tool. And if you see here, this is we can control how smooth we want this object to be. And it did get rid of it, but it still is there a little bit. What I like to use for this instance is actually the erase and fill tool, because it actually erases the body altogether, or the mesh altogether in this area, and it fills it in, and it gives me a flatter result. And I can control the density of it to make it have bigger triangles or polygons, if you may. To make it look more aligned with the rest of the model. So you get a result more like that. Let's say we also wanted to delete this feature here as well. Well, I can go back and delete and increase my brush size. And then I can simply hit, we can go ahead and try erase and fill. We can try to kill two birds with one stone. I was just going to hit delete and then do that. But yeah, you can just do erase and fill. And then you can try to mess around with the density to make it look like more like something that you didn't edit along this model. I didn't want to play around too much with it, but that's the general idea, and it gives you that flat surface. And this is just one of the methods in the Mesh Workspace where you can use to edit your model. All right. So guys, to recap, the first option we used was the mesh to BREP converter in that DeWalt to Makita adapter. So if you have a lot of parametric STL looking model, then I would prefer you use mesh to BREP converter, because you're able to really quickly capture the flat surfaces, and you can delete a couple of faces, and then you have a flat surface you can parametrically model with. We also used T-Spline wrap in conjunction with faces, the match command, and the bridge command. So if you remember the intake manifold on that cylinder, I created two cylinders, or one cylinder, and I copied the other one, did the pull command, and then I added a face in the middle to bridge them together. So that's one of the methods you can use. Another method you can use is that plane along path. And as you create a bunch of different planes, you can use the convert that to a BREP, and then you can use the Intersect tool to create a bunch of different sketches to bridge between or loft between. And lastly, we directly edited the mesh in the mesh environment. We messed around with the mesh palette to make our brush smaller to select in between smaller places. We used the smooth command, and then I used a lot of the erase and fill command. So yeah, write down our emails, email us, call us. If you guys have any questions after the webinar, or if you have any questions right now, we do post these, like Alex mentioned, onto YouTube. So if you guys missed any of it, don't worry, it'll be posted within a week or so. So you can find it there.
Yeah, so looks like we have a couple questions here. One from Bernie. When doing display, why would you not create mesh section in the model workspace? Would that not make it easier to make your sketches? So for those of you that aren't familiar, that actually would, Bernie, it would make things a little bit easier. So for those of you that aren't familiar with mesh section, essentially you create section planes right throughout your model, and think of it as projecting that body onto the plane, right? So depending on the model or the complexity of the model, that would work. For this case, I think Brian chose the method that he went with, because it gave him a little bit more freedom as to where to control, the sketch or the boundary for the model. And then we have another question here from Rita. Can you please elaborate on when you may import cloud points instead of meshes? Yeah, so we'll get back to you on that, Rita, with a more detailed answer, and then hopefully we'll go from there. And then we have, is importing an OBJ quad still a functionality within Fusion?
Yeah, you should be able to import an OBJ file into Fusion. So yeah, go ahead and try that, Daniel, and then let us know if it's not working for you. But you should be able to bring in an OBJ. Oh no, we still have one more. We still have one more question here. It says, is there a way to, is there a way to measure the deviation between the T-Spline model part and the mesh? So there is a mesh tool, or I mean, inspect tool with a measuring ruler that you can use. But there's no, I wouldn't say there's another option besides that. So the inspect tool, the measure tool, and then in the inspect panel.
And also shout out to the Pac-Man team in Fullerton, California. Looks like Daniel. Thanks for tuning in. So yeah, guys, looks like there's no more questions here. For those people that we mentioned that we're going to reach out to, I'm going to do a little bit more research here and then get back to you on the answers. So with that, our next webinar will be on creating fixtures for your part, right? And then adding tool paths to it, right? So if that's something that you're interested in or want to learn more on, tune into our next webinar. So with that, guys, have a good weekend.
Yeah.
See you in the next one.
Thanks for joining us.